Hello, this video is about factoring practice. We're going to review a little bit about the factoring processes that we've been talking about for factoring polynomials. So just as a review, factoring, what we talked about was that if we look at a number like 24, we would find the factor pairs of 24, like 1 and 24, or 2 and 12, 3 and 8. Or 4 and 6. So you factor a number, meaning you find numbers that when you multiply gives you that number. We're going to do the same thing with polynomials. We're going to find the factors that when you multiply give the polynomial. So when factoring, what we talked about is the first thing you always want to try to look for is the greatest common factor. That's what you want to look for every time. So for example, if you have 3x squared plus 9x plus 12, the first thing you might want to think about is there a common factor in all three of these terms? And yes, in this case, the common factor is 3. So the first thing you would do is divide the 3 out of each term. 3x squared divided by 3 is x squared, plus 9x divided by 3 is 3x, plus 12 divided by 3 is 4. And you know you've done this correctly, that if you multiply the 3 through to each term again, you get what you started with. So the first thing you always want to look for is the greatest common factor in a polynomial. Once you've tried and you see either there is or there isn't, then you want to establish what kind of polynomial do you have. Is it a binomial? If it is a binomial, the only kind of binomial that can be factored is if it's the difference of perfect squares. Now, remember, a binomial means that it's a polynomial with two terms. So if it does have two terms, the only way that it's factorable is if it's the difference of perfect squares. Because we've seen in class that any other combination simply won't work. So if you have a polynomial that says a squared minus b squared, here we have a binomial, two terms, a squared and b squared. They're both perfect squares, and there's a subtraction sign between them, so it's the difference of perfect squares. This will factor into a plus b times a minus b. Because the square root of a squared is a times a is a squared, the square root of b squared is b, and the signs have to be one of each. One positive and one negative. Okay? When you have this positive negative pair here, this is called a conjugate pair. Now, obviously, if it's not a binomial, you want to see what your options are. So now the other main kind of polynomial we've been looking at are trinomials. Now trinomials are going to be in the form ax squared plus bx plus c. So we're looking at a quadratic trinomial where a is the coefficient of the leading term, b is the coefficient of the middle term, and c is the constant. So if you've got a trinomial and your leading term is 1, your a is equal to 1, what we've recommended doing is doing what's called your quick factoring. Or, and I'm going to go through an example down below, if your a is greater than 1, if you've got 2x squared or 3x squared, so your a is greater than 1, then it's best to do the factor by grouping. Factor by grouping, which simply avoids the need to do the multiple guess and checks. Okay, so let's review quick factoring of a trinomial. And you would do this when the leading coefficient is 1 here, so it's just x squared plus bx plus c. So the first thing you want to do is look at the sign of the constant, because that's going to tell you what kind of signs you're going to need. When you look at your constant, which is your last term, your C term, if your constant is negative, then when you look at your factor pairs, one's going to be positive and one is going to be negative. And one is negative. So, for example, if you have a polynomial that says x squared plus 5x minus 14, I look at my trinomial, leading coefficient is 1, my 14 is negative, that's my constant. Since the 14 is negative, when I factor this, I know that one's going to be positive and one's going to be negative, one of each, because you need one of each in order to multiply to get a negative product. If my constant is positive, then you're going to have either two positive signs or two negative signs. Because in order to get a positive constant, you need two of the same signs so that when you multiply them, you get a positive. Okay? So you want to look at the signs of the constant. So if you had, for example, x squared minus 9x plus 14, now you know you're going to have two of the same. Well, how do you know if they're going to be two positive or two negative? At that point, you want to then look at the middle term. And the sign of the middle term will tell you what you need. So in this case, I've got a positive 14, which means I've got two of the same sign, but my middle term is negative. So I know that those are going to be two negative signs. So first, you look at the signs of the constant. Then, after you look at the signs of the constant, what you're going to do is you're going to list the factor pairs of the constant, so that you know what your options are. And you want to see which of them adds up to the middle term. So I'm going to figure out which pair adds up to the middle term. So I'm going to go back to the example we had here. We had 14. So what are the factor pairs of 14? Well, it's either 1 and 14 or 2 and 7. Those are really our only options. Okay? So when I'm looking at this question here, I know my signs had to be one of each. And my middle term is 5. So I want to know which combination will add up to 5. Well, if I've got one of each sign, 2 and 7 will work. And my 5 is positive. So it's going to be positive 7 and negative 2 when I do this. And then x times x gives me x squared. So when I multiply this out, x times x will be x squared. Positive 7 times negative 2 will give me a negative 14. And then the middle term will be this right here. 7 times x will be 7x, and x times negative 2. So 7x minus 2x will give me 5x. So I know I've done it correctly. So this is the right combination. Okay. Again, when I look here, 14 is still my constant term, so it's either 1 and 14, 2 and 7. It's positive, so I know the signs have to be the same. And I look at my middle term, and I see that my middle term is negative, so I know they both have to be negative, because a negative times a negative will give me 14, and a negative plus a negative will give me a negative 9. So which combination will give me 9? Well, it's 2 and 7 again, but this time it's x minus 2, x minus 7. Negative 2 times negative 7 will give me a positive 14. X times x is x squared. The negative 2x minus 7x will give me a negative 9x. So I know I have factored this correctly. Okay, now let's briefly review the factor by grouping method. This is helpful when your leading coefficient is not 1. So for example, let's say we've got 2x squared minus 5x minus 3. Okay? Looks like my pen couldn't decide what color to be. So when we have a polynomial like this, and our leading coefficient is not 1, it's 2, the AC method is better. So what I'm going to do is I'm going to multiply the leading coefficient times the constant, the A times the C. So we have 2 times -3 is -6. So instead of looking for the factor pairs of the 3, I'm going to look at the factor pairs of 6. So now the options are 1 and 6 or 2 and 3. Those are my only options. And I see that my 6 is negative. So I know I'm going to have a positive and a negative. It's got to be one of each in order to get a -6. So what combination will give me a -5? Well, if the signs have to be one of each, not the same sign. If I had the same sign, I could use 2 and 3, but I need one of each. So it's got to be 1 and 6, because here I'm now going to rewrite this, and I'm going to use 1x, positive 1x, and -6x. And when I add those together, it's going to give me a -5x. So I just expand my middle term, and I just bring everything else down. I copy down the rest of my polynomial. Okay, now I'm going to factor by grouping. I'm going to look at them 2 at a time. I'm going to look at the first 2 terms, and I'm going to look at the second 2 terms. When I look at the first 2 terms, I look to see what they have in common, the greatest common factor, which in this case is x. So I factor out an x, and when I do that, I have 2x plus 1. Here I look at these 2, and they have a 3 in common. But I see my first polynomial is all positive, and I want this to be all positive, so I'm going to factor out a -3. And by doing that, a negative divided by negative will give me a positive 2x. -3 divided by -3 is positive 1, which is what I wanted. Here, my binomial is now the same. So I'm going to factor out that common binomial. And when I divide it out of here, I'm going to have left x, and here is going to be -3. And there's my polynomial. So it's a pretty quick way to find the combinations. So what I'd like you to do right now is to try the problems on the back, work on them carefully. They're divided up by the type of question that it is, so it should be pretty straightforward just to help us get better at factoring. And please let me know if you have any questions. Thanks.